Hello, good evening. I'm going to talk. I'm Aishwarya Srinivasan. I'm doing a master's in data science at Columbia University, and I'm a machine learning researcher and an algorithm developer. So, in my talks, I'll be talking about how to predict the high frequency trading using the neural networks and text analytics, basically. So, I would be doing this since the beginning. So, I want to let all the people who's watching this know it from the basics, that how things work in machine learning and what kind of data are we working on and how is the prediction will be going on. I'll be starting with high frequency trading. So what do you mean by high frequency trading? Right now, let us consider a situation where a company wants to buy and sell stocks. So it is buying and selling stocks based on the predicted values of the other company's stocks in the market. So what basically is happening is there are a few humans sitting besides the computer looking at the trends of the stock markets and then planning to buy or sell certain number of stocks. If the market rate is really high right now, they would be selling off the stocks. And if it's low, they would buy. And if the predicted rate is high, they would sell it off later. So that is what was used to happen earlier. Right now, what is happening is all of these work is being done by computers. If a person is looking into the stocks and knowing the stock market rates and then predicting to sell or buy it, how would it exactly work when you have things working on in milliseconds? That is where the high frequency trading comes into picture. We develop the algorithms so specific and so sophisticated that the computer within milliseconds looks into all the predicted stock market rates and decides to buy or sell each of the stocks. That is basically what is high frequency trading. So it can be known as a platform where the investment banks or the hedge funds use the high power of the computers to do the transaction in extremely high speeds. The transactions are actually done in milliseconds. So the systems are being using complex algorithms which look into a lot of factors and then understand if it is an optimal time to buy or sell a stock. That is how each and every investment bank or hedge fund company is earning. What they basically do, they sell off the stocks when the prices are going up, and they buy stocks when the prices are going low and would sell them off when the prices are going high later. So now, what is really required in high frequency trading is it's very crucial to have a very powerful decision making algorithm to do it. How would you exactly know within the thousands of stocks which is available in the market which one to pick, which one would go down, and within fractions of seconds? How would you do that? That is how sophisticated the algorithm needs to be, and that is how the computational speed needs to be so high that the algorithm and the machines are able to perform such kind of transactions really fast. So here I want to talk about more number of algorithms which would be doing the decision making here. All the buying and selling part remains with the computational speed of the computers. Right now, I will be telling you more about the algorithms and the strategies that are required to perform such kind of trading. So, just an example in some of the high frequency trading things that happens. So you can see there right here that there are humans who are actually keeping a watch on the stock markets, as I was telling you that what previously people used to do. Now, there are still a lot of companies which do not opt for high frequency trading because high frequency trading requires a sophisticated technology and it costs a lot. Hence, not all companies can spend that much and afford to have high frequency traders with them. Hence, they have like normal computers and algorithms which work maybe on seconds and minutes and do the trading. Right now, so what the high frequency trading does is to maximize its profit, it goes for a lot of unethical things. For example, as you see here, on the rightmost corner, you can see the high frequency traders right there. What is exactly happening is these people are spoofing them. They are giving them fake trades. They are saying that here are some of the trades which you might be interested in. So as all the algorithm works in milliseconds, all the other traders which are in the center, they will be thinking that, okay, these are some of the stocks which might be of my interest. And they would be wasting their computational time on calculating and evaluating on those stocks, while the high frequency traders exactly know where to invest on, and they can be really fast on buying and selling of those stocks. So that is one of the methods by which the high frequency traders are unethically working. And a lot of government laws are working there to stop it. I will talk about it a little later. So yeah, the second thing right here, what is happening is, so the high frequency traders, that is right on the right corner, are giving them that they want to buy a number of stocks at a very high price. So the other traders who are planning to sell it, they would be wasting their computational time on looking to what prices are these people offering. So by the time they see that, oh, this person is offering me a very high price, they try to sell off their stocks to that person. By the time they actually reach there, within fractions of milliseconds, they take the deals off. So the computational speed of the normal traders is being wasted there. Hence, the high frequency traders find out their loops and ways to cover it and buy the optimized stocks and sell it on the highest rates possible. So that is also, there are a lot of laws which are regulating this work. Like the government generally says that the selling and the buying of stocks must be within certain number of seconds. So if you're buying a stock, you cannot sell it for a certain number of periods. So there is a holding time which is required, minimum holding time. After that, only you can sell that stock off. So this is basically how the high frequency trading works. So now, generally, if you see that the stock market rates change, now for a layman, he won't know that why is the stock market changing. I can see the Amazon stock going up from 106 to 107, but why is that happening? Because that is simply because how the calculation is done is they take a percentage of the company's share and evaluate what is the cost evaluation of it, and they supplement it to each percentage wise of stock which they are selling. So that is the cost of each and every stock which you see on the market. Right now, there's a very interesting thing which I would want to tell you is like sentiment analysis. So how does sentiment analysis work? We are taking into consideration the news sentiment, be it from Twitter data, be it from CNN, be it from any finance website, or be it from any other news releasing website related to finance. So there's a really interesting case study which I would like to share with you. It's the Bitcoin. So it was really recent in September 13th that Jamie, he said that Bitcoin is a fraud. It was really surprising because CEO of JP Morgan just comes online and says that Bitcoin is a fraud. The rates of the Bitcoin plungingly decreases. It just decreases by 10%. So could it be, was it supposed to be predicted? If I had bought a Bitcoin, how would I know if the rates are going to decrease or increase? Of course, if I had seen this news before, if I had already gone through the news that what Jamie Dimon had to say regarding the Bitcoin, I would have probably known it beforehand that the rates of Bitcoin would be dropping. So hence, I can plan to sell it off earlier than it happens. That is one of the case scenarios. So people who didn't know about it couldn't sell it, and their evaluation of the Bitcoins just reduced. And after a certain period of time, he took his statement back, and Bitcoin rates again shot up. So there were a lot of controversies which were going on that why was such a statement given and all those things, but we are not going to get there. I just want to tell you how the news sentiment can be efficiently used to understand that how you can predict the data of stock markets for future. For example, If I was a high frequency trader and I could have known that, oh, this is probably the market rates of some XYZ company presently, and then I found a news that, whoa, somebody sued this company. Should I sell my stocks or should I buy more stocks? How would I know about it? So I know what is the news sentiment coming there. It's a negative feedback. So as soon as I find that there's a negative feedback, I know that the prices of the stocks are going to go low. So before the stocks are going low, I should probably sell them off. Or if you are interested in taking more risks, you could probably think of buying the stocks when the prices go low and selling it off later. One of the very interesting things. In this case, we are going to specifically look at the Amazon data. So everybody knows about Amazon. There's like nothing to say about Amazon. Amazon has a lot of products, web services. It's a product and service based company. So and it's a highly flourishing company. So I have specifically taken the Amazon data for one tiny reason. That was, first of all, there were two specific dates when the Amazon stocks really went high. One was a really obvious reason. Why? Because Amazon bought Whole Foods. This was one of the crucial understanding things. Amazon bought Whole Foods. The stock prices of Whole Foods went high. The stock prices of Amazon went high. So we're just gonna see that what news was it. So Amazon buys Whole Foods for $13.4 billion. Amazon is buying Whole Foods. Why is Amazon buying Whole Foods? So obviously there was some strategy which was planned by Jeff. That's why he would have bought the Whole Foods company. So obviously he knows that is going to make his stocks go high. That's when we know that the Whole Foods rocket shoots up by 28%. News sentiment. What could be observed from this? There's a very high positive reaction that we are getting from the news regarding Amazon. Amazon is buying a whole huge flourishing market of companies. What would we know? The next day, on 15th of June 2017, the rates were 963.857, and on 16th, it shot up to 995. Amazing, isn't it? So the next case was there. Maybe not very evident, but it was there. During the data analytics, it was found that during the Amazon entering Singapore with one of its product called Prime Now, what could have possibly been happened? It was exactly on 26th of July. If the high frequency trading would have extracted all the news sentiments, it would know it. Another thing, Amazon just opened a new lab dedicated to healthcare. Amazon is investing big time, isn't it? Yes, it is. So Amazon is investing big time. Its stock market is ought to go high. So does it. Amazon could be the first trillion-dollar company with stock doubling to $2,000, leading data analysts say. Exactly, they would say the same. So, what do you think the stock prices would have gone up to? 1044 to 1082, highest till date. It was gone up on 27. So this is a very crucial inference that we should make, that how a news sentiment can be affecting your various other prediction capabilities. So just for an example, I would just not focus on this case scenario, but then I would want all the listeners right here to understand that how you can think about various other things which would probably affect one of your crucial things which you want to predict. Just for example, let's say I would want to predict the stock market itself. So why not look it into a broader perspective? Why not, if I'm looking at certain XYZ company stock markets, I would also look at the indices that are related to the company. If it's an automobile company, I should look at the stock markets of the mining oil refineries and petroleum companies and steel production companies and all. Have have you ever thought about doing that? It would be so amazing if we can get like really great inferences from them. We can probably know that, oh, how a mechanical automobile company can be very well predicted. The stock markets can be very well predicted based on a lot of other things. So it can be a very crucial way of doing it. Another example could be once we are looking at like just for an example, a lot of people must be knowing about the app called Fantasy. So yeah, fantasy sports. In fantasy sports, what generally happens? You just invest on few of the players. So while we are investing on few of the players, what you generally do is like a lot of people are investing on certain famous players a lot of money. Right then, if you know that, oh, these are few of the players who are really famous, but there are only few of the people who are investing on it. How would we know that? We just extract a lot of Twitter data, other feeds, and then have a comparative study at who all are the most spoken about players, and then see that how many people are investing on each of these players. That is one of the very interesting ways of doing it. So let's come back to our study right here. I have used the minute-wise data of the Amazon stock starting from 1st of March to 31st of August so that I could have that time span between which there was a fluctuation in the rates. It was during July and June. It was 16th of July and 27th of July to be precise. So that was used, and a very common index to use is the Dow Jones index. And I have used some of the news sentiment data. So news sentiment data was a very crucial parameter during the study. This is just a snippet of the data. So you can see the date, time, Dow Jones index, and sentiment data. We have 3 sentiment data related to it. I would explain more on that. Then there's a news volume. That is exactly about how many news of Amazon, how many percentage of news of Amazon is present in the whole set of other newses. And then we have the news buzz, which is just the pointer which we are giving. That's a parametric between -5 to +5. Exactly the same with the sentiment. Then we have open, high, low, close, and the volume of the stocks sold on that particular time. So this is just a brief explanation of the sentiment data. So it measures from the bullishness to the bearishness of the equity. We have the scale of -5 to 5, where I have implemented some of the algorithms where it compares the newsfeed data with the natural language processing techniques and extracts whatever relevant keywords are there, brings it down to the qualitative data into quantitative data, and gives it a factor. So that factor ranges from -5 to +5, -5 being extremely bearish and +5 being extremely bullish. So next we go for the buzz scores, which are the normalized values, which are deviation of the news volume which is happening. And then, as I told you, the news volume is nothing but the number of news related to Amazon among all the other newses. So this is a brief overview of the whole study. As I told you, the basic objective is to predict the minute-wise stock price of the Amazon Inc. So I need to know what is the next minute's stock price which can be predicted using the streaming web data which I'm getting, streaming news which I'm getting, and the previous minutes opening, closing, and high-low value, and of course the Dow Jones index. So the strategy was to build a predictive model, and here we are using a neural network, not to just take a specific neural network and train it for the model. I wanted to have a comparative study so that we could know that, oh, these are few of the models and these are the efficiency of each of the algorithms. Because however efficient you try to, even if you're trying to justify your algorithm to be extremely efficient, it cannot be done so because it entirely depends on the data set. So for few of the data sets, like for a few of the concave functions or convex functions, depending on the data set, the efficiency of the algorithm changes. For few of the algorithms, maybe radial bases would be highly efficient compared to multi-layer perceptron. We will be talking about that in a minute, both the algorithms which have been used. So that is something which we cannot specify that this is the algorithm which is going to be the best. So there are a few questions coming up right here. So I can see that there's somebody who's asking that how do you crawl the financial news section? So it's just a small piece of Python script which you can write to scroll only the text part or just the news section, the textual news section in each of the websites. That's a pretty simple thing. You can probably leave your mail address, Alisa, here so that I can send you a snippet of the code. And the next question is where do you, okay, the same question repeats again. And it's Line Chani. Please leave your email address here. I'll get you back. Then the next question is, financial news of Amazon. So what I mean by financial news of Amazon is things which would be affecting the stock price. So if somebody says that Amazon is planning to expand, or Amazon is going to sue somebody, or Amazon is going to buy, those are the kind of news which I would relate to the financial stock markets of Amazon. Hence, those are the specific news I would target and then try to do the natural language processing. Here, there were a lot of news snippets which I got and I had to ignore them. Like if somebody is putting up posts related to what they found on an Amazon website, something related to accessories or clothes, or how was their review about Amazon Prime or something related to that. So those all are the data which we need to filter out. So that was a tedious task to write down the algorithm where it extracts only the effective data from the whole set of news related to Amazon and then find the sentiment data for it. So the next question is, Ephraim says that he wants the code snippet as well. Sure, Ephraim, can you please leave your mail address right here? The next question is by Lanchani. My means that these data set from CNN or some website. So the news is not specific to any website. The news has been taken from websites like CNN. It has been taken by websites like Stock Tweets and Twitter and a lot of others. So it's like a numerous number of websites from where the data has been extracted and analyzed upon. So would you please leave your email address right in the comments so that I can get back to you? Thank you so much. And I'm sorry to all the people who are waiting for me to continue this talk. So yeah, I was talking about the strategies which need to be built such that the predictive model is working efficiently. For all those people who don't know a lot about neural networks, I would want to say that neural network is nothing but a way which you're training the model other than regression or any linear model. So in regression, what we generally do is we give certain number of coefficients to each of the parameters and try to make it a function. Try to make it look like a function. Here, what we try to do is like we create layers between the input layer and the output layer, input being whatever parameters we want to give to the model and output of what we want to be predicted. So here, if we see in the neural networks, you can have the hidden layers, which would be nodes, which are termed as nodes, and each node has its own activation function. I would just go regarding the activation functions. So the variables which are used in this analysis are the dependent variables, which are open, close, high, low. Oh my god, okay, there's slight change here. It's open, close, high, low, and volume, which we want to predict. And the factor variables are nothing but the date and time. If somebody is not very familiar with what variables are and how do you do the classification of the variables, they can very well go and look into explanations of what nominal variables are, what ordinal variables are, what scale variables are, what factor variables are, and what covariate variables are. So next we are going for covariate variables, which are nothing but the Dow Jones index, sentiment data, and the news buzz data. Let's go to the algorithms which were used in this study. First was the multilayer perceptron with the activation function of sigmoid. The second was the multilayer perceptron with the activation function of hyperbolic. And the third was radial basis with the hidden layer activation function as normalized. I would go through each and everything through this PPT. So what do you mean by a multilayer perceptron? So multilayer perceptron is a way by which you train the whole network for its efficiency to predict what you want on the output node. So when you're sending the data through the MLP, what happens exactly is you're initially arbitrary giving the weights to each and every edge of the network. You're letting that weight seep into each of the nodes, let it have its process with the activation function and output a value from each of the nodes, and subsequently it goes on that output getting a weight on the next edge and going forward to the next node. So that's how the backpropagation algorithm works. I would cover what backpropagation algorithm is. So in backpropagation algorithm, what we do is in the initial step, as I was mentioning, that you give a weight to each and every neuron. So what a neuron is it's the edge for which you give each and the weight to. So right here you can just see. So there are I1 and I2, which are the input node, H1 and H2, which are the hidden layers, O1 and O2, which are the output nodes. We are just considering one layer of hidden nodes here, but in the analysis done, it's not just one. There are multiple hidden layers. That is why it is. So what basically deep learning is, it's just the number, how you increase the number of hidden layers such that your estimation becomes very efficient. So here if you see that there's only one hidden layer, how the calculation is being done is from the input node I1, there's a weight associated with the hidden node 1, that is W1. From I1, there's a weight associated with H2, that is W3. From I2, there's a weight associated with H1, that is W2. From I2, there's a weight associated with H2, that is W4. The same goes from H1 to O1, which is W5, H2 to O1, which is W6, H1 to O2, which is W7, and H2 to O2, which is W8. There is a bias, which you can see there, which says 1, and there's a B1 written on the edge. That is nothing but a constant factor that contributes to each of the node as an input. So right now, how would you calculate it? So let me explain you in a brief way how does this network work. So you have, this is basically initially used for the training purpose, and then we go for testing. So this works basically for training initially. How does it work for training? We know the values of the output. We know the values of the input. What we need to design is the middle part. We need to set the weights. We need to set the activation function such that it merges my input, processes it, and then produces my output in a way. So here exactly what would be done is initially there are arbitrary weights which are given to each of the edges like W1, W3, W4. Everything will be assigned with some random value. Then the network is run. It's seen that if the W1 weight with the I1 input is entering H1, then exiting it with the weight W5, would I be getting the output O1? No. Hence, we change the weights. Hence, we work upon the weights and see that if there is any better way of putting the weights such that each and every time we are getting the output value with least error. That is how the backpropagation works. We start initially with random values and then propagate back to see if what weights would be required for us to get the optimal output. So that is basically one of the things which happens. So right here, I would want to tell you one more thing. Okay, there are a few more questions right here. They want align Chani. I need some tweets. Okay. The Twitter of Amazon sentiment. I don't think it is a good idea to unite scraping and sentiment analysis in the first place. Alisa, I would really want to know more about it. It would be great if you could put in a detailed comment of what you mean and what would be your suggestions. So by scraping, I meant scraping the news data from the websites of the news and not a general scraping about just like any random things. So just for the people who know about internet programming, you can view the source code of the website and see that how the whole framework of the website works, where all you can specifically find the texts of the news. Hence, I scraped it in such a way that only I get the news content and nothing else. So, if there is any clarifications, I would really love to hear it from you, Alisa. So, there are a few more things which I want to tell you regarding the backpropagation algorithm. Ren has a question. Would the idea not be to respond to the changes in sentiment during HFT? You need to respond to the changes in sentiment during HFT. That is why I was talking about getting the streaming data. So while we are scraping, while the Python script is continuously running and scraping the sentiment data and running the process of the sentiment analysis, that is when you're getting streaming data of the sentiment values, and that plays a major role in doing the HFT. So that's one of the major things which we are using in the neural networks to train it in such a way that it understands what is going on in the market and what were the trend data to predict a new value, such that the HFT knows to buy or sell the stock at certain time. So I would go on, continue with the next part of it. So yeah, a very important thing right here, if you can see that, as I said, that the first multi-layer perceptron is having the sigmoid activation function. People would ask, what is an activation function? So people who don't know, I would really want to tell you about it. So activation function is nothing but a function which is applied exactly at the hidden nodes. You can see H1 and H2 right there. So the activation function is applied on H1 and H2. The H1 takes in an input, say X, and puts out another output. So that transformation from X to f of X is nothing but my activation function. So here we are using the sigmoid activation function, which is nothing but 1 upon 1 plus exponential negative of that value which we are getting. So that is a very simple way of, that's the sigmoid one, which is generally used in most of the hidden nodes. And the other one was the hyperbolic function. The output is nothing but the hyperbola of the X value. That was the other activation function which we were using. So now let's go to the radial basis neural network. So as I've told you how the multi-layer perceptron works and how the backpropagation algorithm works, I would like to go to the radial basis. So radial basis also uses basically a mathematical function as a activation function to take in an input and put out an output. But the basic crux of what it wants to do is something of a classification. It has to not only just predict the values, right? In the radial basis neural network, we have the function which you can see right here. So you see x minus c of I. The c of I is called a center vector. So that value needs to be generated by the radial basis. That is why it is termed as a radial basis, because you need to know what that center is, and you need to train your model so efficiently so that it gets accustomed to the pattern of the data, the whole data set. So to determine the value of CI, we generally use the k-means clustering. That's like the most widely used part in the algorithm. So yeah, I would really like to explain this more. So radial bases work based on two different steps. The first, as I explained, was to calculate the centers of the radial basis function of the hidden activation layer, and the second is to fit a linear model of the coefficients yi. So the wi, okay, there's a error with the like what I call it. Yeah, the ai which you can see right here is nothing but the weights. So the weights, as I was mentioning in the backpropagation algorithm, there are weights in the radial basis function also, which connect each and every node with the next node. So those weights are also fitted using a linear model. These are the two basic steps which are done. So here's a basic difference. How can I put it in a mathematical form? What is the difference between a multi-layer perceptron and a radial basis function? So the multi-layer perceptron basically uses the dot product, that is the input and the weights. There's a dot product which is calculated between the input and the weights, as both the input and the weights are represented as vectors, and then there's a dot product which is calculated, and the sigmoid activation function is done through a backpropagation, as I have mentioned to you. This type of neural network is used in deep learning, as I was telling you, that as you increase the number of layers, hidden layers, your neural networks approaches deep learning. Now, before anybody misinterprets it in a way, I would really like to say that it is not that if you put like n number of hidden layers, if you start increasing the hidden layers, your model will become efficient. It is not at all like that. There is a very, very thin layer of difference between deep learning and overfitting of data. So if anybody has doubts regarding that, they can please leave a comment right here if they have doubts regarding the overfitting of data. So I assume that people would know about overfitting of data. So here's a very thin line between the deep learning and overfitting of data. If you put in like 5 layers, 5 hidden layers, your efficiency of the model might be say 0.95. If you're putting 6th layer, it might be say 0.96. But it might be that if you're putting the 7th layer, the efficiency might drop down because there's a lot of sparsity in the data. That is one of the reasons why people should understand that not increasing the number of hidden layers is the highest or the best way of deep learning, and it will not increase the efficiency. As you're increasing the hidden layers, your calculation becomes more sophisticated, and you're nothing but training a model to overfit your data. It will just work for the data with which you trained it with, and it will not work efficiently with the testing set of data. So then we have the radial basis function right here. So right here you can see what the radial basis function. It's just the Euclidean distance between the input and the weights. So you can see that the radial basis is different from a multi-layer perceptron, because in the multi-layer perceptron we are converting the data into the vector form and then taking dot products. But in radial basis, it's just the inputs and outputs Euclidean distance which is calculated and worked with. So here we have the Gaussian function or the normal function, whatever you call. So that is used as the activation function. Hence, it is known that the radial basis neuron have the maximum activation with the center weights equal to the inputs, because it's obvious, because when the center weight becomes equal to the input values, the overall precision of the model improves. So here we'll just go and see what the results are, to see how each and every model is working efficiently in predicting the values. So we had around more than 50,000 minute-wise data which we had, and then we had like 3 predictive values which we took. 2 of them were from multi-layer perceptron, and 2 of them were from radial basis, just changing of the activation functions. So you can just see the graphical representation of how the predicting value is working. So I'm just going to put this on complete screen so that you can see. So the blue one, which you're actually not properly able to see, was the actual open data which was available. Then you can see the green one in some of the spots. So and then you have the light brownish color which is also going through. So each and every green, brown, violet and yellow are nothing but the predicted values which are going through the whole function, and the blue one is the actual value of the open data. So you can see that apart from the purple one, violet one, and some parts of the green one, the other two functions are performing really great. So one is the green and the other is the yellow. So the green is the multi-layer perceptron and the yellow is the radial basis with ordinary activation function. As I said that we had different activation functions which we can use on the hidden layers. I had trained two of the models with multi-layer perceptron with different activation functions, and two of the models with radial basis function with two different activation functions. And the same goes. This was the open value which was predicted. This was the high value which is being predicted. This is the low value which is being predicted. And this is the close value which is being predicted. So right here, if you can see, I would really want you to understand what the precision of each and every function is working like. So I hope everybody here knows about square error and everything. Is there anybody who is not well versed with square error? I'm waiting for your responses if everybody is well versed with square error. Okay, so there's a question. Would the idea not be to respond to the change? Would the idea not be to respond to the changes in sentiment? I guess I answered this, that yes, you have to respond to the changes in sentiment data while you're predicting the HFT. And the next question is the impact of the knowledge graph on the stock. Do you have some idea? The impact of the knowledge graph on the stock. Lion Cheney, I'm not able to understand your question. I'm really sorry. Would you like to frame it in a better way so that I can understand? Alisa. So she says, what do you think of genetic component altering the architecture of the neural network? So the architecture of the neural network is initially fixed while you're training it in a particular way. You can form the outer algorithm which try to run multiple times the same neural network to see which one is the best way, which one is the best number of layers, which is the best number of hidden nodes in each of the layer, which would give me the higher precision of the value. But then basically, while you're doing it on a single perspective, you can just take like few alternatives of the number of hidden layers and number of hidden neurons in each of the layer and then do the testing. Otherwise, it becomes very sophisticated where you have to put an outer loop to test with n number of different cases of number of hidden layers and nodes, and then understand that which either of the multi-layer perceptron or the radial basis function with how many hidden layers and with how many neurons in each hidden layer will give me output. So that is a huge process to complete with it. So right here, if you can see, as it was visible in the chart which I showed you, the mean square error here is 0.125 with the training set and 0.132 with the testing set, which is very obvious because you've trained the model using the training data. Hence, it has to be more efficiently working with the training set and a little less efficient, which is intuitive to have with the testing set. If you can see 1.25 and 0.125 and with the hyperbolic activation function, 0.135 and 0.141 with the sigmoid activation function, and 0.510 and 511. That's really a lot of error with the radial basis activation function. As I was telling you, you cannot predict that radial basis function would be working best for this or not. So here you can see that the multi-layer perceptron, specifically with hyperbolic function, was working best with the case. This cannot be actually termed as the best, but in the cases we analyzed, this comes out to be the better one. You can have more number of use cases and see which model performs the best. Otherwise, you can probably use some of the softwares to do it for you, which will be you can just like feed in the data, and people who are like not well versed with much of the coding, you can probably use some of the softwares to do it for you. You can just have to do the data cleaning and filtering and then feed in the software with the data, and it'll do everything for you. Thank you so much for hearing me. Thank you so much.